Welcome. Today we want to look on partial differential equations. So we want to know what is a partial differential equation. So a PDE is an equation stating one dependent variable, say u, with two or more independent variables, say x, y, t, and the rest, and the partial derivatives of u with respect to this independent variable. That's how we can define partial differential equation. So its solution is found by the equation, or generally this is how we present a partial differential equation. So now we want to see the methods of solving a partial differential equation. The first method is by solution by direct integration. So we want to see some examples of how we can solve partial differential equation by direct integration. So for example, you are asked to solve the equation d squared u over dx squared is equal to 12x squared into brackets t plus 1. You are given the initial condition that at x equals to 0, u equals to cos 2t, and du or dx equals to sin t. So we want to see the solution here. So the first step is to integrate this equation partially. So integrating it partially, we have du will be integrating this equation with respect to x. We have this will be like an arbitrary constant when we were carrying out ordinary integration. So that was our first step, integrate partially. Then we integrate partially again. So integrating partially again, we find that this is the equation we get. So now at this point, we apply the boundary conditions. So our boundary conditions were that at x equals to 0, u equals to cos 2t, and du dx equals to the sine of t. So therefore, you see du and u. So we want to see what these equations represent here. This equation du dt represents, because if it will be formed in the auxiliary quadratic equation when we were dealing with ordinary differential equation, so this one will be the second term, or we write it by saying, and our u then will be, yes, so that is it. Now therefore write our final solution to be u So let us see another example. Here now you are required to solve for this equation, and you are given this initial condition. So in this equation, it is a derivative of both x and y. So we want to look now we can solve it. So so the first step here is to integrate partially with respect to x. So it will be so when we integrate sine, we get negative cosine. So this is the first step. And now we apply the boundary conditions. Here we are given that at y equals to 0, du dx equals to 1. So applying these conditions in this equation, we find so therefore x so therefore we can write our equation as so the second step is now to integrate this equation now also partial. So by integrating it we have, so this one will be a function of y because we were integrating with respect to y. Therefore applying the other boundary condition, that's so applying this boundary condition into this equation, we find that so therefore this function of y will equal to so our final solution will be presented as simple as that. So that is our final solution. So we want to look at another method of solving partial differential equations. So this method involves solution by initial and boundary conditions. It is not of much difference from the first method, that is direct integration, only that it includes both initial and the boundary condition. So the boundary conditions may involve the final conditions. So let's say now you will need to solve the equation d squared u dy dx equal to sine of x and the cosine of y, given the conditions. These are the conditions you have. So I want to see how we handle this. Integrate partially with respect to x. So we have the equation. But now applying our first boundary condition that at y is pi over 2, then du dx is 2x. So therefore here we say that x so remember here pi over 2 is 90 and sine of 90 is 1. So that's how the equation is solved. Sine is again so that means that so we have substituted this equation in this place. So this one equal to, so by factorization that's what we find, and now we can get our u to be, so but now this is our general solution. So for us to get the particular solution, we apply the second boundary condition, which was that at x equals to pi, u is 2 sine 1. So therefore we say by substituting x we find the solution, and by applying this second boundary condition. So remember, this equation was found by integrating this equation with respect to x. So here, this is now the equation we find. So we want to find what is this function of y. No, you should remember that the cosine of x now, which is pi, will be negative 1. So here our equation becomes so expressing this function of y will be equal to. So this is basically the equation theta with the function of y. So coming and replacing it in this equation, then now we have our particular solution of u to be. So this is our particular solution. So those are the two basic methods that are used in solving partial differential equation. So for more videos and tutorials on this topic, please subscribe to our YouTube channel, like it, comment, and share to your friends. These are the DMM tutors, the best local tutors so far. Thank you for watching.